Welcome to Get Your FRQ On. This question is from 2010. It's question number 1, and it is calculator active. In the question stem, we have snow falling on a driveway at a given rate with a function f of t. And this continues from midnight until 9 a.m. And at 6 a.m., a person named Janet begins to remove snow from the driveway at given rates. The rates do change at a specific time. So we take this information. We have part A, how many cubic feet of snow are on the driveway by 6 a.m. Well, if we have a rate for how quickly snow is falling onto the driveway, the total amount of snow on that driveway without any removal would be just the integral from t equals 0 to 6 in this case of that rate function. So the total amount of snow accumulated by 6 a.m. is found by just integrating the rate function, which is given in the question stem, for snowfall between t equals 0 and t equals 6. Now it's important to understand here that at 6 a.m. Janet begins to remove snow, so at least up until 6 a.m. we do not need to account for that. All right, so the calculus that we do have to do here is the integral from 0 to 6 of the given function f of t dt, which is the integral from 0 to 6 of 7t times e to the cosine t. And since this is a calculator active, we're going to use our calculator to do this. And it turns out that approximately 142.275 cubic feet of snow has fallen on the driveway by 6 a.m. In part B, we are asked to determine the rate of change of volume of snow at 8 a.m. Now, one thing that's important to understand here is that the rate of change of volume of snow at 8 a.m. now must take into account the rate at which snow is being added, f of t, and the rate at which it's being removed by this person, Janet. So this is going to require a couple of different moving pieces in order to set up the calculus to do this. All right. This is what's known as an in-rate, out-rate problem. In-rate, out-rate problems can show up in a lot of different formats, but this is basically the structure. The rate at which something is happening is given, and then something counteracts that, and that rate is given, and then you kind of have these like competing rates that you have to account for. Right, so the desired rate is equivalent to f of 8 minus g of 8. F of 8 is the rate at which snow is falling at 8 a.m. G of 8 is the rate at which Janet is removing snow at 8 a.m. And so we just have to set up this difference. Well, f of 8 minus g of 8 is just the function f evaluated at 8 minus the function g evaluated at 8. And again, since this is a calculator active question, we can set up the expression we need to evaluate, but ultimately we're going to let our calculator do it. It turns out that the rate of change of volume at 8 a.m. is about negative 59.983 cubic feet per hour. In part C, we define a new function h of t to be the amount of snow removed t hours after 12 a.m., and we are asked to write the function h of t as a piecewise function. Right? So we have a couple of different parts here. We know that Janet doesn't start removing snow until 6 a.m. So the first sort of breaking point or boundary point for our piecewise function seems to be somewhere 0 to 6 a.m., since that's easy to define. Right? But since no snow is actually being removed between t equals 0 and t equals 6, then our h of t function, which gives the amount of snow removed, should just be 0. The only thing that's happening between t equals 0 and t equals 6 is snow is being added. It's not being removed. So that would just be 0 for t between 0 and 6. Okay. Well, Janet removes snow at two different rates depending on what time it is. So we have to break apart our piecewise function to account for both of those. All right, so the first interval is from 6 to 7, and the amount of snow that Janet is going to remove between 6 and 7 is going to be h of 6, which is how much snow has been removed specifically by 6 a.m., plus the integral from 6 to t of g of x dx. But we already know h of 6 is 0 since no snow has been removed up to that point. So we have 0 plus this integral. Well, the rate function g of x is just 125 for that period, so right, we apply the fundamental theorem of calculus, and that expression would be 125t minus 750. That applies for t between 6 and 7. All right, but then we have a different rate of snow removal from 7 to 9. That h of t would be h of 7 plus the integral from 7 to t of g of x dx. All right, but h of 7 is 125. So that's our h of 7 plus the integral from 7 to t of 108 dx. Well, okay, 108 t minus whatever 108 times 7 is. It's apparently 756. And then we add back the 125 from before, and we have 108t minus 631. So now we have the three parts of our piecewise function. H of t is equal to 0 whenever t is between 0 and 6 because no snow is being removed. H of t is equal to 125t minus 750 when t is greater than 6 but less than or equal to 7. And h of t is 108t minus 631 when t is between 7 and 9. So it's greater than 7, less than or equal to 9. In part D, we are asked to determine how many cubic feet of snow are on the driveway by 9 a.m. Right, so the amount of snow on the driveway by 9, again, needs to account for the amount of snow removed since 6 a.m., in addition to any freshly fallen snow that hasn't been removed yet. So again, we have a couple of different things to account for here. So we have all the snow that's falling between 0 and 9, and then we have to account for how much snow was removed between 6 and 9. All right, so we want the total amount of snow, which is this, that falls between 0 and 9, so midnight and 9 a.m. Then we have to take away any snow that was removed between 6 and 7 at the rate that Janet was removing snow between 6 and 7. Then we have to subtract the snow that was removed by Janet, which is now at a different rate, between 7 and 9. And whatever this value of this expression is, that's how much total snow is on the driveway at 9 a.m. It's the absolute total snow that fell minus the amount that Janet removed, and Janet removed snow at two different rates depending on what time we're talking about. All right, so the integral from 0 to 9 of 7t e to the cosine t dt minus 125t minus 750 evaluated between 7 and 6 minus 108t minus 631 evaluated between 9 and 7. That will be our total snow. But again, this is a calculator active question. Please do this with your calculator. Do not allow yourself to make an arithmetic mistake here. The value of this expression turns out to be 26.335 cubic feet of snow on the driveway at 9 a.m.